Let's take a look at central angles and arcs. A central angle is an angle with its vertex at the center of the circle and its two sides are radii, which is the plural for radius. The sum of all the central angles in a circle is 360 degrees. So if you're looking at the illustration to the right, angle ABC is a central angle because its vertex, which is B, is the center of the circle. Its two sides, segment AB and segment CB, are both radii, which makes it a central angle. Think central angle at the center. Remember, with angles, you can always use 3 letters, but making sure that the vertex is in the middle. So you could call that angle ABC or CBA. Because that is the only angle in the figure, you could also call it angle B. The degree of the arc formed by the endpoints of the central angle is equal to the degree of the actual central angle. So arc AC, which is directly between A and C, which are the endpoints of the angle, would also be 84 degrees since the angle ABC is 84 degrees. So the measure of arc AC is 84 degrees. Now, the measure of arc ADC, so make sure when you're looking at the arcs, go in that exact order. ADC, so that's everything else, would be equivalent to 360 degrees minus 84, which would be 276 degrees. As discussed before, there are 3 types of arcs. There is a minor arc, which would be less than half of a circle, less than 180 degrees. There is a major arc, like arc ADC. You definitely have to use 3 letters for a major arc. You can use 3 for a minor arc, but you're not required to. A major arc is more than 180 degrees, but less than 360 degrees. And then the semicircle is exactly 180 degrees. That's half of a circle. All right, so in this circle, N is your center, and we are told JL and KM are diameters. And that's really important because knowing that you have a diameter means you have half of a circle or a semicircle, which is 180 degrees. So you're asked to find some of these other angles and arcs. So I'm actually just going to talk about the figure and we can worry about what we're asked to find in just a minute. So I'm going to go kind of talk about some of the information we discussed last semester. So one of the things we talked about a lot last semester were vertical angles. So vertical angles are still a thing. They don't disappear. And we definitely have a pair of vertical angles in here. Angle JNK is going to be the same thing as angle LNM because they're vertical angles, and vertical angles are always congruent. That's the vertical angle theorem. One of the other things we also talked about last semester were a linear pair. And when you have a linear pair, that means you have 2 angles that are adjacent or next to each other that make a line. And all linear pairs, since they form a line, are 180 degrees. So if angle JNK is 20 degrees, then that means in order to find angle KNL, which would be this one right here, we could do 180 minus 21, and 180 minus 21 would be 159. And likewise, because of vertical angles, or you could do the linear pair for angle JNM, it would also be 159 degrees. What's nice is that since N is the center, you have several central angles, and so the arcs formed by their endpoints are going to be equivalent to the actual angle. So from J to K, that is going to be 21 degrees. And from M to L, that will also be 21 degrees. From K to L, that would be 159 degrees. And from J to M, also 159 degrees. So we have everything we could possibly need, all angles and all arcs. So let's look at what they asked us to find. So the first thing was the measure of J and M. Make sure you go specifically in that order. J, start at J, go to N, and then go to M. So that's that angle on the left, which is 159 degrees. Arcs from J to K, that would be the one that we just talked about, JK right there, 21 degrees. K to L, we talked about that guy already, that's 159 degrees. Then we have JKM, so we're going to start at J, we're going to go through K, and we're going to end at M. So not quite the whole circle, but it's definitely 3 of those arcs fit together. So you can add 21, 21, and 159. That's one way to find it. So that's going to be 201 degrees. The other thing you could do is you could say, well, it's everything besides JM, and you could subtract 159 degrees. 360 minus 159 would also give you 201 degrees. And then the last arc we're looking for is MKL. So we're going to start at M, then we're going to go to K, and then we're going to go to L. We're going to end at L. So that is the entire circle except for ML. So you can either do 360 minus 21, or you can add 159, 159, and 21. And that will get you 339 degrees. So just like when we were doing Unit 2 and some of you struggled with finding the angle measures, you need to make sure that you read the letters in that very specific order because it's quite important. All right, in number 2, we know that UW is a diameter, and we know SV is also a diameter, and that makes X the center because diameters go through the center. We also have that angle TXU is 87 degrees. So this angle right here, 87 degrees, it is a central angle. So that is going to mean that arc TU will also be 87 degrees. We also have that arc SW or WS, whichever you want to call it, is 72 degrees. And the central angle that intercepts that arc is SXW, so that means SXW is going to be 72 degrees. So to find everything else, we're going to have to use the knowledge that we already have. Since WU is a diameter, that means that WS, arc ST, and arc TU should add to equal 180 degrees. So if we take 180 and subtract 72 and 87, that should give us the measure of arc ST, which would be 21 degrees. And that also means that this angle right here, that central angle TXS, is going to be 21 degrees. So those 3 angles add to equal 180, and so do the 3 arcs. Now we can do one of 2 things. We can use vertical angles if we want, which I think is probably the quickest thing to do. Angle UXV is vertical to angle SXW, which means they are both 72 degrees, which means UV is also 72 degrees. You could also do the same concept and look at SV being a diameter and know that ST plus TU plus UV has to equal 180 degrees. All right, the last thing that we need to find is WV, and there are multiple ways to do that. So since you know the whole circle is 360, you could subtract 72, 21, 87, and 72 from 360. But we also know that UW is a diameter, so UV and VW have to equal 180. So if I do 180 minus 72, that's going to give me 108 for WV, which also means that the central angle WXV is 108 degrees. So now let's look and let's see what they're asking us to find. So the first thing, angle UXV. So UXV is starting at U, go to X, and go to V. That was the vertical angle. That is 72 degrees. And now let's look at our arcs. S to T. That's just directly from S to T. It's got to be a minor arc. That is right here. We already figured that out. That's 21 degrees. W to V. W to V is the arc in green. We already figured that out. That was 108 degrees. The measure of TSW. So you're going to start at T, go directly to S, and then end at W. So that would be right, I'm going to highlight it, TSW. So that is those two arcs together, 21 and 72, so that would be 93 degrees. And then finally, our last arc, we're going to start at T, go to V, and then W. So highlight it so you can see it a little bit better. Start at T, V, and at W. So that's everything we're subtracting out that 93 degree arc that we just had. Or you can add 87, 72, and 108, and that will get you 267 degrees. So again, you can either do 360 minus 93, or you can do 87 plus 72 plus 108. It really kind of depends if you see it as adding all of those pieces or subtracting out the other pieces. It's kind of just however your brain works. All right, in number 3, we have that CE is a diameter and DG is a diameter. That makes point H the center. We also have a right angle at CHD. So if CHD is a right angle, we know that's 90 degrees, which means from C to D is also going to be 90 degrees, which is actually the first thing they ask us to find. So go ahead and put that down. We also have that arc EF is 34, and so its central angle, which is EHF, would be 34 degrees. So you could call that angle EHF or FHE. You definitely cannot say just H because there are multiple angles coming from H. And that does not look like an angle there. Actually, we're not looking for any angles. All of the measures we're looking for are arcs. All right, so now what we need to do is we need to go based on what we have. So since CE is a diameter, then that means arc CDE is a semicircle. It's 180 degrees. So that would mean that to find arc DE or to find angle DHE, we would need to do 180 minus 90, which means that that's going to be a 90 degree angle. Oops. So that's 90, and this is also 90. And likewise, the same thing is going to be true for arc CG. It's going to be 90 because DG is a diameter, which means angle CHG is also 90 degrees. And then finally, to find the last arc, you can do it several different ways. You can do 360 minus 90, 90, 90, and 34. Or if all of those other ones are 90, that kind of means that G to E needs to be 90. So you can do 90 minus 34, which is going to give you 56 degrees. So this angle, let's find a color I haven't used, 56. The arc is 56 degrees and the angle is going to be 56 degrees. So now we should be able to find everything. So the first one we're looking for is FED. So we're going to start at F, go through E, and end at D. So that's the FE and ED put together. So 34 and 90 put together would be 124. The next arc that we're looking for is DCF. So we're going to start at D, travel through C, and then go to F. So D, C, and then end at F. So that's everything besides what we just found. So we could do 360 minus 124. You could also do 90, 90, and 56. So that is going to put that at 236 degrees. And our final arc that we're looking for is GDF. So we're going to start at G. We're going to go through D and then end all the way to F. So that is the entire circle minus GF, which is 56 degrees. So 360 minus 56 is going to give us 304 degrees. All right, so for number 4, also we've got some diameters. QS is a diameter, and so is RT. That makes U the center, which means we've got a bunch of central angles. We've got a 19-degree angle, and we also have a 90-degree angle. So let's look at that 19-degree angle first. That would be TUS. So that means TS or ST, arc, is going to be 19 degrees as well. Because of vertical angles, that's going to mean that QUR or RUQ is 19 degrees, and arc QR is going to be 19 degrees. And then because you have that 90-degree angle, that would mean that angle PUQ and QUR should equal 90 degrees. If we do 90 minus 19, that's going to give us our other angle, which is 71 degrees, making this 71 degrees as well for arc PQ. If angle PUR is 90 degrees, and we know RT is a diameter, that also means that angle PUT is going to be 90 degrees and arc PT will be 90 degrees. And then finally, to find arc RS, you can do 360 minus 19 minus 71 minus 90 minus 19, or since RT is a diameter, that makes RT a semicircle. So if we do 180 degrees minus 19, that will give us 161 degrees, and that will be the measure of arc RS and also angle RUS. So let's look for the arcs they're looking for. PQ, we already have, that's 71 degrees. SR is, that's one we just found, 161 degrees. QRT, so make sure on these, make sure you're following the order. Q, R, and then ending at T. So it's 19, 161, and 19, or you've got a semicircle plus 19 degrees. However you want to look at it, your preference should be 199 degrees. All right, the next one we're looking at is arc PSR. So let's start at P, go through S, and then all the way to R. So that's everything besides PR, which we know is 90 degrees because we have that right angle. So 360 minus 90 would be 270. And then our last arc that we're looking at is arc PTS. So that's actually not a major arc, even though it uses 3 letters. So P to T to S is 90 and 19. So you're looking at 109 degrees. So the next 3 examples are similar to what we were doing in the first 4, but here you're going to be solving for x. So you may not be finding as many things, you might just be finding x, or you could be finding more. And actually this one, it kind of got cut out. All you're doing for this problem is just finding x. So we need to think about what we have and how we can find x, and you want to make sure that you don't make any assumptions. So when you look at this picture, we're told that EG is a diameter, and we're told that FH is also a diameter, which means we have some semicircles. We know I is the center. So what I would do is find what you can find and then think about how can we incorporate the 18x minus 2 and solve for x. So if EG is a diameter, so that means that arc EFG, so this arc right here, would have to be 180 degrees. And so since we already know that FG is 103, if we do 180 minus 103, we'll get 77 for arc EF. So I'm going to go ahead and throw that on there. EF is going to be 77 degrees. And now, if we know that HF is a diameter, then that means this arc right here, FEH, is also 180 degrees. So those three measures, 15, 18x minus 2, and 77, should add to equal 180 degrees. So one way to tackle this is just to add those three things and set them equal to 180 degrees. You could break it down a little bit more and make it easier. I don't know that it makes it easier, but it might make more sense to you. So I'm going to kind of show you some options. So the first option would be to do 15 plus 18x minus 2 plus 77 equals 180 degrees and solve it. Now, what you might want to do is use the central angles. So for instance, if FG is 103 degrees, then FIG is 103 degrees. If EF is 77 degrees, then EIF is 77 degrees. If DH is 15 degrees, then angle DIH is 15 degrees. And what you might want to do then is say, okay, well, what's 180 minus 15 minus 77? Because that will give me EID, which is 88 degrees. And if that's a central angle, then it should be equivalent to its intercepted arc, ED, which is 18x minus 2. So then you could just do 18x minus 2 equals 88 degrees. So it really just, again, depends kind of how your brain works and how you see it. So you can set it directly to its measure, which is probably what I would do, or you could add the three arcs and set them equal to 180 degrees since they do form a semicircle. It's complete preference. So I'm going to do 18x minus 2 equals 88, and then hopefully that's just a simple solve for you. Add 2 to both sides, 18x equals 90. Divide both sides by 18, and x will equal 5. And on this one, it cut out, but in your notes, that's all you're doing is finding what x equals. In number 6, we're actually doing a little bit more. We are looking for x, and then we are solving for some specific arc measures. So the first thing we got to figure out is how do we find x, because without x, we can't find any arcs. So we do know that MK is a diameter and JL is a diameter. And if JL is a diameter, then that means that arc JK and arc KL are a semicircle, or they equal 180 degrees. So I'm going to add those two and set them equal to 180 degrees. So I'm going to do 5x. So kind of like what I was talking about in the last one, but this is your only option because you don't have any specific degree measures. 17x minus 41 equals 180. All right, so the first thing I'm going to do is combine like terms. I'm going to combine the 5x and the 17x, which gives me 22x. And then I'm going to combine the 23 and the minus 41, which would be negative 18. And that gives me 180. Now I'm going to add 18 to both sides to give me 22x equals 198. And then I'm going to divide both sides by 22, and that is going to give me the value of x, which is 9. And then I can use that value to find everything else. So to do that, I'm going to plug 9 back in. So I'm first going to try plug 9 back into JK. So I'm going to do 5 times 9, and then I'm going to add 23 to that. And that is going to give me, let's see what it is, 45 and then 23, so 68 degrees. So the measure of JK right here is 68 degrees. To find KL, you can do KL one of two ways. I'm going to plug it in just to check. You could also do 180 minus 68, but let's say you made a mistake finding X. If you do that, then you're still going to have a mistake. So if I do 17 times 9 and then subtract 41, it gives me 112. And now I know that I did this right because 68 and 112 do add to equal 180. But we are not looking for KL, we're looking for MJ. And MJ is actually going to be equivalent to KL because if KL is 112 degrees, then angle KNL is 120 degrees. And by the vertical angles theorem, JNM would be 112 degrees, making JM 112 degrees. I'll go ahead and mark angle JNK as 68 degrees, and that makes MNL 68 degrees, which makes arc ML 68 degrees. The last thing we're looking for is arc LMK, so make sure you start at L, go through M, and end at K. That is everything besides that 112 degree arc, so 360 minus 112 will give you 248 degrees for arc LMK. All right, in our last example, we're looking for X and then 4 different arc measures. We know we have a 90-degree angle as VZY has that 90-degree mark on it. So that means that arc VY is going to also be 90 degrees. We have that arc YX is 10x plus 9. We have arc VW is 8x, and we have arc WX is 2x minus 12. Here, we're not told that we have any diameters, so we don't have any semicircles. We don't have any vertical angles, so the only thing we can really do here is use all 4 arcs and add them together and set them equal to 360. So that is exactly what I'm going to do. So I'm going to have 8x plus 21x minus 12 plus 10x plus 9 and then plus 90 equals 360. And I've got a lot of like terms to combine. So I've got 8x and 21x, so that's 29x, and then 10x, so that gives me 39x. And then we have negative 12 plus 9, which would be, what, negative 3, and then add 90 to that, so that'd be a positive 87 equals 360. Now, this should be a lot easier. Subtract 87, so that gives us 39x equals, and 360 minus 87 is 273. We're going to divide both sides by 39, and that will give us that x equals 7. So now that we know what x is, we can plug it back in to help us find each of those arc measures. So for VW, 8 times 7 is 56. For WX, we're going to do 21 times 7 and then subtract 12. So that's going to be 135 degrees. And then finally for XY, 10 times 7 plus 9 is going to be 79 degrees. All right, so let's see what they want us to find. WX, 135 degrees. We already found that one. YVW. So start at Y, go to V, end at W. So that's two of our arcs combined. That's 90 and 56. So that's going to be 146. The next one we're looking for is YX. And we already have YX. That's 79. And then the final one that we're looking for, we are starting at V. And then we're going through X. And then ending at W. So it is the entire circle except for VW. So we're going to do 360 minus 56. And that will give us 304 degrees.